So what if I told you that the lightning-fast, highly responsive engine that's basically powering almost every modern web app you use today was actually born out of a desperate attempt to fix PHP?
I mean, it sounds completely absurd, right? But it's true.
Yeah, welcome to the deep dive. Whether you're, prepping for a major engineering meeting, or maybe you're just trying to decipher all the front-end jargon your dev team throws around, or honestly, if you're just insanely curious about how the digital world actually functions, you are in the right place.
Definitely. And, our mission today is to completely decode React.
Right, exactly. We're going to totally bypass the dry code syntax. Like, we're not doing that today. Instead, we're going to focus on the architecture, distilling this massive topic down into clear aha moments for you.
Yeah, and that origin story you just mentioned, that is the perfect place to start. Because React, which is this absolute powerhouse JavaScript library for building user interfaces, it started in a totally different ecosystem.
It really is a phenomenal paradox. I mean, to truly understand why React works the way it does today, you have to look at the massive bottleneck Facebook hit around, 2010?
Yeah, 2010, exactly. They were dealing with an infrastructure largely built on PHP, and they had created this clever extension called XHP.
XHP, right.
Yeah, and its primary goal was to allow developers to write custom, reusable, HTML-like elements directly inside PHP. But its superpower was actually security.
Okay, wait, security, how so?
So it automatically neutralized cross-site scripting attacks. Like if a malicious user tried to inject dangerous code into a comment or a message, XHP would basically sanitize it before it ever rendered.
Oh, wow. So is it like an automatic filter?
Exactly. And it was highly successful at keeping the platform secure.
Well, I mean, security is great, obviously, but XHP lived strictly on the server,
Yeah,
right?
entirely server-side.
So if you were building a highly interactive, dynamic web application, you were essentially tied to a tether. Like you click a button, a request travels all the way to the server recalculates the page, and then sends the whole thing back.
Yeah, and making even a tiny microscopic change to the user interface meant the entire page had to re-render.
I always think it helps to think of this old server-side model like having to completely demolish and rebuild your entire house just because you wanted to change a single light bulb in the kitchen.
That is exactly it. And that is computationally exhausting, bandwidth heavy, and just incredibly slow for the user.
I can imagine.
Yeah, I mean, when you're a company trying to build a live, dynamically updating news feed where people are constantly liking, commenting, and sharing in real time, that full house demolition approach is a dead end.
Right. The browser just couldn't handle the constant tearing down and rebuilding of the DOM, right? The document object model.
Precisely. So the problem was super clear. The server round trips were just killing performance.
Which leads directly to 2011 when a software engineer named Jordan Walk built a prototype called FaxJS.
Yeah, FaxJS. He took that secure component-based idea from XHP, but he pivoted the entire concept away from the server and brought it directly into JavaScript on the client side.
And moving that logic into the browser, that was the critical shift, wasn't it?
Oh, totally. By letting the user's own machine handle the interface logic, you eliminate that massive server bottleneck completely.
So they deployed this new JavaScript architecture on Facebook's news feed and then ported it over to Instagram in 2012 when they acquired them, just to prove it could scale.
Yep, and it did. So by May 2013, they open-sourced it to the world at a conference called JSConf US under the name React.
And the development community immediately revolted. Like, they absolutely hated it.
Oh, the initial backlash was intense. I mean, for over a decade, the golden rule, the absolute dogma of web development was the separation of concerns.
Right, like keeping everything in its own little box.
Exactly. You kept your structure in an HTML file, your design in a CSS file, and your logic in a JavaScript file. You never mixed them. And React came along and completely obliterated that boundary with something called JSX.
Right, JSX, which stands for JavaScript XML. And it essentially allowed developers to write what looked exactly like HTML tags directly inside their JavaScript logic.
Which, to people at the time, felt like a massive step backward into the dark ages of messy, tangled code.
Like, what are you doing to my beautiful separation of concerns?
Exactly. It looked like a total violation of best practices. But what those early critics missed is that JSX is just syntactic sugar.
Okay, unpack that a bit for us. Syntactic sugar.
Basically, it's an illusion. It's designed to make the code highly readable for human beings. When a React application actually builds, all those HTML-looking tags are transformed by a compiler into a standard JavaScript function.
React.createElement, right?
Yes, React.createElement.
Yeah.
So underneath the hood, JSX has the full, unadulterated mathematical and logical expressiveness of JavaScript. It just uses a familiar visual template.
Okay, so we have this controversial new syntax. But to actually build something with it, React introduced a fundamental distinction that I think trips up a lot of people. The difference between an element and a component.
Yeah, those terms get thrown around a lot, and they are definitely not the same thing.
Let's use a physical analogy here. For you listening, think of a React element as a specific physical Lego brick sitting on your desk. Like it's a blue 2x4 brick.
I like that.
It is a plain, immutable JavaScript object. It is a lightweight description of what you want to see on the screen at one specific millisecond in time. And importantly, it cannot be changed once it is created.
Right, immutable. And because it's just a lightweight description-like, it's not an actual heavy piece of the browser's DOM React can create and discard millions of these elements in the background almost instantly.
Wow, millions. Okay.
Yeah. Now, to continue your analogy, if the element is the physical Lego brick, the component is the factory mold that creates the brick.
Oh, that makes perfect sense.
Right. A component is a reusable piece of code, like a function or a class, that takes in some data and then returns a React element.
So you build the mold once, and you can stamp out thousands of unique bricks depending on what color plastic you pour into it.
Exactly. You build a like button component once, and you can render it on every single post in a feed.
And this modular architecture is what allows engineering teams to scale these massive applications. You break a monolithic, sprawling interface into tiny, isolated blueprints.
Yeah, a component for a navigation bar, a component for a chat window, maybe a component for a user avatar. They are totally independent.
Which means a bug in the chat window doesn't crash the navigation bar.
Exactly. But, the way developers actually write these components has shifted drastically over the years.
Right, because if we look at older React code bases, they're full of class components using this really clunky object-oriented JavaScript syntax.
Oh, yeah. But then React 16.8 dropped in early 2019, I think, and it completely flipped the script by introducing hooks.
Why did they need hooks? What was wrong with classes?
Well, classes were highly problematic for a few reasons. In JavaScript, this keyword inside a class behaves in very confusing ways depending on how a function is called, which just led to endless bugs.
I've heard that. This keyword is basically a meme at this point.
It really is. And furthermore, as a component grew, its life cycle, the code that runs when it mounts to the screen, updates, or is removed, that life cycle became a tangled mess of unrelated logic just smashed into the same class methods.
So hooks solved this by allowing developers to use simple, clean JavaScript functions instead.
Exactly.
But wait, a standard JavaScript function just runs its code, returns a value, and then forgets everything that just happened. It has no memory.
Right, it's stateless.
So how do you build an interactive application if your components have amnesia every time they render?
That is exactly what a hook does. A hook, like a use state, for example, allows a simple function to basically hook into React's internal memory engine.
Oh, I see.
Yeah, when the function runs, React secretly holds on to that piece of data behind the scenes. So the next time the function runs, React hands its saved data right back to it.
So it gives functional programming the power of stateful memory without the chaotic baggage of classes.
You nailed it. Today, class components have practically vanished. They're kept around mostly for legacy support or highly specific edge cases.
Like error boundaries, right?
Exactly, which act as a safety net to catch crashes in a specific part of the UI before they take down the whole app.
Okay, so functions can now hold memory, which brings us to the actual engine of the application. If a component is just a blueprint, how does it know when you actually type a message or click like?
Right, how does the data actually move around?
Yeah, and this relies on three core concepts, as we found in the sources: props, state, and events. Let's start with props, which is short for properties.
So, props are the inputs. They are how a parent component passes data down to a child component.
Like passing instructions down.
Yeah, like if you have a user profile parent component, it might pass a prop called username down to an avatar child component.
Got it.
And the critical rule here is that props are strictly read-only. The child component cannot modify the data it receives from its parent.
And this is where I really have to question the logic. I mean, this is called unidirectional data flow. Data only flows downwards, but why?
Why not two-way?
Right. If I have a child component, say a text input field, and the user types their name into it, why can't that child component just update the username prop directly? Wouldn't two-way data binding be infinitely easier?
It feels easier right up until your application grows beyond a single page, and then it becomes a catastrophic debugging nightmare.
Really? A nightmare.
Oh, absolutely.
Hmm.
Imagine a massive dashboard where 50 different components all have the power to spontaneously change the underlying data whenever they feel like.
Oh, yeah, I see where this is going.
Right. If a user's name suddenly disappears from the screen, how do you find the culprit? You would have to trace an endless, tangled web of spontaneous changes.
So forcing the data to only flow one way is basically a structural guardrail.
Exactly. It enforces predictability. It's analogous to a strict chain of command in an organization. Clear reporting lines prevent chaos.
So if a child component needs to change data, it doesn't just quietly alter the prop. It sends a message, an event up the chain to the parent saying, hey, the user just typed a new name.
Precisely. And the parent is the one that actually holds the state.
State being the second core concept here. So while props are read-only data passed from the outside, state is private, mutable data managed internally by a component.
Yeah, that's the distinction. When the parent receives that event from the child, it updates its own internal state.
And when a component's state changes, that is the trigger that tells React, hey, my reality has shifted, I need to re-render and generate a new set of elements.
Right. And then it passes that new state back down the chain as fresh props.
Which creates a beautifully predictable loop. But doesn't it also introduce a massive performance risk? Like, if a parent component re-renders, by default, every single one of its child components will also re-render, right? Even if their specific data didn't change.
You're exactly right. That can be a huge issue. And this is where React offers an optimization tool called React.memo.
React.memo. So this basically wraps around a child component and acts like a bouncer at a club.
A bouncer. I like that.
Yeah, like before it lets a re-render happen, it looks at the new props coming down from the parent and compares them to the old props. If they are identical, it stops the re-render dead in its tracks to save processing power.
It does what is called a shallow comparison, because deep comparison in programming is incredibly slow.
Deep comparison meaning?
Well, it means inspecting a piece of data, opening every single nested folder inside of it, and checking every single file to see if a single comma changed.
That sounds exhausting.
It is. So a shallow comparison just looks at the memory address of the data. It checks the front door. If the address is the exact same, it assumes the data is the same and completely skips the render.
Brilliant. Now, this flow of data is entirely driven by user interaction, which brings us to events. And React handles user events like clicks and keystrokes a bit differently than plain HTML. They use a system called synthetic events.
Yeah, synthetic events are basically a normalization layer. If you've ever dealt with early web development, you know that a click event in an old version of Internet Explorer behaves very differently than a click event in Chrome or Safari.
Oh yeah, the bad old days.
Oh, totally.
Huh.
So React intercepts all native browser events and wraps them in a synthetic event so that they behave identically across every single browser on the planet.
That is so convenient.
It really is. It also forces developers to use camel case naming, so onClick with a capital C instead of all lowercase, and requires you to explicitly call prevent default if you want to stop default browser behaviors like a form submitting and refreshing the page.
Makes sense. Now, there is a vital detail tied to rendering these dynamic lists of data that we have to talk about. The key prop.
Oh, yes. The key prop, super important.
Right, because whenever you render an array of items, like a list of comments or a shopping cart, React demands that you assign a unique string or number to each item, called a key.
Because without keys, React is essentially flying blind. I mean, think about it. If you have a list of 10 items and you insert a new item at the very top, how does React know you added one at the top versus shifting all 10 items down and changing their text?
It wouldn't know.
Exactly. The key is the unique identifier that lets React track an element across time.
And a major pitfall developers run into is trying to cheat this system, right? Like generating a random key, using something like math.random on the fly, or just using the item's index order in the array.
Oh man, using math.random completely destroys the architecture.
Really? Why is it so bad?
Well, if an item's key is a random number, then every single time the parent component re-renders, that item gets a brand new key.
Oh,
Yeah, so React looks at the new key, panics, assumes the old item was completely deleted, and builds a brand new one from scratch. You lose any internal state that item was holding, and you completely tank the application's performance.
So keys must be stable identifiers tied directly to your data, like a database ID.
Exactly.
Right.
Stable and unique.
Which perfectly sets up the ultimate question here. We have state constantly shifting, events firing, components triggering massive cascades of re-renders and lists dynamically reordering.
Get a lot of activity.
It is. So if React is generating all these new elements constantly, how does the browser not just crash? How do we avoid the original problem of demolishing the house to change the light bulb?
And the answer to that is React's crowning technical achievement and the mechanism that makes all of this possible, the virtual DOM.
The virtual DOM. Let's break this down for the listener.
So the virtual DOM is a lightweight, in-memory representation of the actual browser DOM. When you tell React to render your application, it doesn't immediately go and start moving heavy, slow HTML nodes around on the screen.
Right. Instead, it creates a ghost copy. It helps to think of the virtual DOM as a MIDI director's storyboard.
Okay, I'm following.
Imagine a director has a massively complex scene with hundreds of actors, heavy lighting rigs, and elaborate set pieces. If they want to see if moving an actor to the left looks better, they don't force the entire crew to physically move everything just to test it out.
No, that would take hours.
Exactly. Instead, the director takes out their pencil, erases a figure on the storyboard, and sketches them in the new position.
That is a great way to visualize it. That initial storyboard is the first render. Now, a state change happens. Let's say a user clicks a button. React essentially drafts a brand new second storyboard showing exactly what the UI should look like now.
But crucially, it still hasn't touched the actual browser screen.
Nope, not yet. This is where the magic happens. The diffing algorithm.
The diffing algorithm.
Yeah. React places the old storyboard and the new storyboard side by side and plays a lightning-fast game of spot the difference. It systematically compares the two trees of data to find exactly what changed.
And this ties directly back to why those list keys are so important, right?
Exactly. The diffing algorithm uses those keys to quickly match elements from the old tree to the new tree. Once the diffing is complete, React moves to the final phase, which is called reconciliation.
Reconciliation. So what happens there?
It calculates the absolute minimal set of instructions needed to update the screen. It hands those precise instructions to the browser, which then updates only the exact elements that changed, the single light bulb instead of the whole house.
Okay, just a quick point of clarification for you, the listener, because the terminology can get really muddy here. You might hear the term shadow DOM thrown around in front-end circles.
Oh, yeah. That confuses a lot of people.
The virtual DOM and the shadow DOM are completely unrelated technologies, right?
Correct. Completely different things. The shadow DOM is a native browser technology used for web components. Its job is encapsulation. It hides CSS styles and variables inside a component so they don't bleed out and accidentally ruin the styling of the rest of the web page.
So it's about style protection, basically.
Yeah. The virtual DOM, on the other hand, is purely a JavaScript concept implemented by React to optimize rendering speed.
Got it. So React has this incredibly efficient storyboard system, but as web applications grew from simple pages into massive desktop-class software operating in the browser, even the virtual DOM started to hit limits.
They definitely did. And that brings us to React 16, which introduced a complete rewrite of the core rendering engine called React Fiber.
React Fiber, what made it so different?
Well, before Fiber, React used a synchronous stack-based algorithm for rendering, meaning once the director started sketching the new storyboard to calculate an update, they could not stop. They had to finish the entire calculation before the browser could do anything else.
Oh, so if the user triggered a massive data update.
The main thread of the browser would be completely blocked. The screen would literally freeze for a few milliseconds, causing animations to drop frames and feel janky.
Wait, pause for a second. If Fiber fixes this by interrupting a render halfway through, doesn't the user see a broken, half-drawn screen? Like, how does the browser not display a half-rendered mess?
That is the brilliance of the two-phase system in Fiber. All of that interruptible work, the calculating, the diffing, it happens entirely in memory during the render phase. It's completely invisible to the user.
Oh, so the screen isn't touched at all yet.
Right. The screen isn't touched until the commit phase, which is still perfectly synchronous and instant. Fiber introduced the ability to break that invisible background work into tiny chunks, and more importantly, it introduced prioritization.
Prioritization.
Yeah.
So the director can now prioritize the actors.
Exactly. Say the engine is halfway through calculating a massive data table update in memory, but suddenly the user types a character into a search bar.
The search bar is obviously higher priority because the user expects instant feedback.
Right. So Fiber allows React to pause the heavy data table calculation, immediately process the keystroke so the UI feels buttery smooth and responsive to the user, and then pick right back up on the data table calculation where it left off.
Wow.
Yeah, it supports true concurrency, working on multiple versions of the UI simultaneously. It is an astonishing feat of engineering that keeps complex apps feeling completely fluid.
It really is. So just look at the journey we've taken today. I mean, React started as a server-side PHP experiment just to stop cross-site scripting and avoid full-page reloads.
Right.
It evolved into a JavaScript library that shocked the development world by mixing HTML and logic with JSX. It established a rigid, predictable hierarchy with unidirectional data flow through props and state.
Yeah, it completely rewrote the rules.
And it ultimately revolutionized browser performance by pioneering the virtual DOM and the concurrent interruptible rendering engine of React Fiber.
Understanding this architecture, it gives you such an incredible lens into how the modern digital world operates. Even if you never write a single line of code, you now know the mechanical reasons why the applications you rely on every day feel so fast and intuitive.
Exactly.
You understand how staggering complexity is managed through modular components and predictable data chains.
Yeah.
You are literally looking at the foundational blueprint of the modern web.
It truly is a masterclass in solving cascading problems. But, I want to leave you with one final thought to mull over, because technology never stays still. We saw that React was born out of a desire to escape the limitations of the server, right?
Yeah, escaping PHP.
They moved all the rendering work into the user's browser to make interfaces dynamic and instantaneous. But today, the absolute newest frontier in this ecosystem mentioned in our sources is something called React Server Components.
Which is exactly what it sounds like.
Look
Moving the rendering of components entirely back to the server in order to ship zero JavaScript to the client and reduce bundle sizes.
Right. It really makes you wonder, are we destined to just keep swinging like a pendulum between the server and the browser?
Definitely feels like a loop sometimes.
Yeah, is the history of technology simply a spiral where we continually rediscover and re-implement old ideas just at a higher, more dizzying level of complexity? It really makes you wonder if 10 years from now, we'll end up right back where we started, staring at our screens, waiting for the server to finish demolishing the house just so we can change a light bulb. Thanks for taking the deep dive with us.